Hello everybody, welcome back to yet another video of FikarNot.com, now FikarNot from studies. So today we're going to start a brand new chapter of chemical equations and reactions. A very interesting chapter, in fact, talking about the chemical changes and the reactions that each compound element goes under. So without further ado, let's get into this chapter. So some syllabus that we are going to cover in this chapter will be the types of chemical changes, direct combination, decomposition, displacement, double decomposition, energy changes in chemical reactions, and etc. So starting with the introduction, chemical reactions. What do we understand by the term chemical reactions itself? When I say chemical reaction, what's the first word that pops up in your mind? Personally, for me, the first word that pops up in my mind is reactants. So, what is a chemical reaction actually? A chemical reaction is a chemical change in which matter changes into a new substance or substances, which actually, if you break this definition down, it makes complete sense. So like always, let's try to break this definition down. First four words. A chemical reaction is a chemical change. Of course, it's a chemical change. Why? Because let's say I take hydrogen H2 plus O. What do I get? H2O. It's a chemical change, right? Because hydrogen is changing and is combining with oxygen to form water. So it is going under a chemical change. In which matter? Any matter. Let's say in this case, what is the matter state? Liquid, water, right? So matter changes into a new substance or substances. So matter over here, in this case, gas. Two gases are combining, hydrogen and oxygen, to form a new substance or a new matter state, which is, in this case, what is it? It is water, H2O, right? So it is forming a new substance or substances. And in a chemical reaction, the substance or substances taking part in the reaction are called as reactants. So in this case, H2 and O are called as reactants. And H2O as a whole is called as the product. It is called as the product. So in a chemical reaction, the substances or substances taking part in the reaction is called as the reactants, and the reactants are transformed into one or more new substances called products. So it can either be one or it can be many, right? Depends on different chemical reactions. In this case, we have H2 plus O, but in different chemical reactions, we have different products. So now once we have break down this whole definition, doesn't it make sense? So therefore, without looking this time, a chemical reaction is a chemical change in which any state of matter, say gas, solid or liquid, changes into a new substance or a new state or even new substances. And in the chemical reaction, the substances undergoing the reaction, the chemical reaction, are called as reactants, and the new product form is called as the product, or the new substance form is called as the product or products. Second one, chemical reaction, the procedure. So now that we've got to know what chemical reaction as a term stands for, what do you think chemical reaction as the procedure stands for? As in, what is the procedure of a chemical reaction? What procedure does it go under to form a chemical reaction? So during a chemical reaction, the existing bonds of the atom or groups of atoms of the reactants are broken and new bonds are formed, resulting in the formation of new substances called products. So again, let's break this down, alright? What does it say? During a chemical reaction, the existing bonds of the atoms or groups of atoms of the reactants are broken. This means that if I have N2, let's take the same example given in your textbook, N2 plus O2. gives 2NO, right? Because you're balancing the equation also. So existing bonds of the atoms, existing as in over here, you have existing bonds of 2 nitrogen atoms and 2 oxygen atoms. Both of these bonds are broken to form what? To form one product called as what? Nitrogen oxide. In this case, right? So you're taking nitrogen plus oxygen to give nitrogen oxide, and they are broken and new bonds are formed, resulting in the formation of new substances called products. So they're undergoing a chemical reaction, as you can see over here, right? They're undergoing a chemical reaction, as you can see over here, under a certain temperature that combines both of them together. And what do you get? You get a new product. So you have two nitrogen and 2 oxygen combining to form 2NO. And the bond is the linkage or force which acts between two atoms to hold them together as a stable molecule. It is called as the chemical bond. So over here in this case, a nitrogen and oxygen are in a chemical bond. They cannot just be separated by physical methods like hand picking or sieving or boiling, evaporating, nothing like that. It can, right. So as I was saying, this is how a bond is formed, right? And none of the physical methods like hand picking or sieving, they cannot just remove these bonds, because these bonds are chemically formed. They're chemically formed together to form one whole bond. Therefore, what is it called now? A chemical bond. And therefore, both of them have gone under a chemical reaction, and this is the whole procedure. So now that we have done the term, the procedure, how do we actually represent a chemical reaction? Well, a chemical reaction is represented by a chemical equation, and it is a shorthand form representing the result of a chemical change. For example, let's take an example over here that's written CaOH the whole twice plus 2HNO3, right? So on the left hand side, we are writing the reactants and the substances which take part in the reaction, right? So over here, this is just a normal chemical reaction, but you can also write the word equation of this. That's calcium hydroxide plus nitric acid, which in this case is dilute. Now the products formed in this case by the displacement reaction will be Ca will start combining with NO3, alright, and the OH whole twice will combine with hydrogen, which will form 2H2O, if you see. How? Because in this case you have 2 oxygen atoms, 2 hydrogen atoms, and in this case plus you have 2 hydrogen atoms, which together forms, you can say 2H2, that's 4O. Make sense? 2H2O, right? And in this case CaNO3 the whole twice. That's right. So you get a total of 6. How? Because in this case again, you can see oxygen has 3 atoms, 3 into 2, 6 atoms of oxygen. And how many atoms of nitrogen? 2. 2 atoms of nitrogen. So therefore, when you do whole twice, that means 2 atoms of nitrogen and 6 atoms of oxygen, because 3 into 2 equals to 6. So therefore the equation is completely balanced, and this is the shorthand form representing the result of a chemical change. So left hand side you have the reactants, right hand side you have the products, and when we want to read it as a word equation, you would say calcium hydroxide plus nitric acid gives you calcium nitrate plus water. Alright, and this is your complete reaction. Alright, let's go to the next page now. Chemical reactions, the characteristics. So chemical reaction is often accompanied by external indications or characteristics. Let's say first characteristic of indications accompanying a chemical reaction. So now what do they mean over here? What do you mean by accompanying a chemical reactions. What is the textbook trying to say to you, or what are the people trying to say to you over here? They're trying to say uh, whenever two or more substances go under a certain chemical reaction, they show a few indications that something has changed in it, right? Let's say, for example, when you take any two substances, right, and they have an indication of color, their color slightly changes, so you get to know, oh, some chemical reaction has taken place over here, right? So certain indications are given to us which prove that the two substances that we have combined actually are going under a chemical change, a chemical reaction. And there are 4 to 5, to be exact, 4 indications that the substances give to us, saying that yes, we have combined together or we have displaced together and we have gone under a chemical reaction. So the first one, the first most simple indication is the change of color. Let's say we have copper nitrate, okay, 2CO, Cu, sorry, 2Cu NO3, the whole twice, gives you 2CuO plus 4NO2 plus O2. Now in this case, copper nitrate turns blue and copper oxide turns black. So this is the color change. In this case, as you can see over here, this is copper nitrate. Copper nitrate originally was blue in color, but then after it got heated on, it formed copper oxide, which changed the whole substance into black. So this is one color change. Similarly, if we take lead nitrate, 2PbNO3, the whole twice, gives 2PbO plus 4NO2 plus O2. So in this case, lead nitrate originally was only white, but after that, it turned into yellow. That's litharge. And so over here also you have a change of color. Second one, evolution of gas. So what do you mean by evolution of gas? Well, a very basic example would be sodium sulfite with dilute sulfuric acid. Fine. In this, SO2 as a product is evolved. A gas is evolved. A gas is formed in this reaction. And when a gas is formed or a gas is evolved or the evolution of a gas comes out, we know a chemical reaction has taken place, because a gas cannot just simply evolve, right? If in this case we have sulfur dioxide being evolved, we know a chemical reaction has taken place. Similarly, carbon dioxide has been evolved, so a chemical reaction has taken place. And again, similarly, ammonia has also been evolved. So all of these are gases and they have been formed as products, and therefore we know that a chemical reaction has taken place. Third one, formation of a precipitate. This one is the best example of all. Apart from change of color, of course, formation of precipitate is something we see very often, right? Let's say we have lead nitrate plus sodium chloride, right? You all know this experiment very well. A white precipitate is formed whenever you add both of these. Now, when a white precipitate is formed, we know that certain chemical reactions, right, when they're formed together, they form an insoluble precipitate that cannot be mixed with the chemical reaction. And that is your product as well, and therefore we know that's a precipitate. Similarly, copper sulfate and sodium hydroxide. The product that they give is Na2SO4 plus CuOH, the whole twice. So in this case, copper hydroxide is a pale blue precipitate, and it is an insoluble precipitate which is left behind, but yet it is still a product. So therefore, from this we know that a chemical reaction has taken place. The last and final one would be evolution or absorption of heat. Reactions which proceed with evolution of heat energy are exothermic. Reactions which proceed with absorption of heat energy are called as endothermic. A few examples would be nitrogen plus hydrogen. It's an exothermic reaction, meaning evolution of heat energy is there. What do you mean by this? 2NH3 plus an evolution of heat. That means heat is a product. So whenever you combine both of them, a heat energy is produced, and that is what you call as the evolution of heat energy. And therefore we know that a chemical reaction has taken place. Similarly with nitrogen and oxygen, right? You have nitrogen oxide, and in this case you have minus heat energy. This means that heat energy has been absorbed from nitrogen and oxygen, and that's why it is minus the heat energy. But in the first case it was exothermic, which is this. An easy way to remember this would be exo meaning XO, meaning coming out, removed. So evolution of heat energy is taking place. Endo meaning finished, done. So absorption of heat energy is taking place, and therefore the heat energy is finished, done, right? So it's an easier way to remember it like that. Moving on, let's now see some types of chemical changes. We have about 4 types, and they're very easy. All you need to do is honestly learn the examples, but we're of course going to break each one down and we're going to see what they all stand for. Okay, so the first one we have is direct combination reaction. That means when A plus B or 2 or more elements or compounds combine, they form AB, one new compound. Right? Or you can almost say not even direct combination reaction, you can just say it is combination reaction, because 1 or 2 more elements or compounds are coming together to form one new product. Similarly, in decomposition reaction, AB, as in only one chemical compound, is forming 2 or more products, A plus B. So both of them are decomposing. They are splitting up to form 2 or more compounds. Or you can say plus C also, it can be there, who knows. Then third one, displacement reaction. So in this case, you have A plus BC. Let's say in this case, as you can say, magnesium plus CuSO4. So something is being displaced. So magnesium gets combined with SO4 and Cu is left alone. So you're displacing the reaction. So if I had to say in the form of letters, A plus BC, A starts combining with C, so the product would be AC plus B. They're displacing the reaction. Then you have double decomposition reaction. Okay, double decomposition reaction meaning A plus B minus plus C plus D minus gives you A plus D minus and C plus B minus. So it's almost like again displacement reaction, but also decomposition at the same time. For example, if I take AgNO3 plus KCl gives you AgCl plus KNO3. So look over here carefully what's happening. Ag, let's take Ag as A. A plus B, right? A plus B plus C plus D. Okay, so A is combining with D and B is combining with C. So it is double decomposition reaction. Things are getting displaced from here to there, but 2 times. Not only 1 time, but 2 times. So A is displacing with D, but B is also displacing with C. So you can also say double displacement reaction because compounds or elements are getting displaced from here to there. Alright? So a chemical reaction in which 2 or more elements or compounds react to form one new compound is called as direct combination reaction. Then a chemical reaction in which a chemical compound decomposes into 2 or more similar substances, like thermal decomposition reaction brought about by heat, or photochemical decomposition brought about by light, is called as the decomposition reaction. Then a chemical reaction in which an element or radical has replaced another element in a compound is called as displacement reaction. And then a chemical reaction in which 2 reactants are both decomposed to form new substances by exchanging their radicals is called as double decomposition reaction. Perfect. So now let's go in depth of all these reactions and let's see what all these reactions stand for and what they exactly mean. Starting off with direct combination reactions. Direct combination or synthesis reaction basically means, as we just read out, two or more compounds combine to form one new product. Okay, so direct combination reaction are also called as synthesis reaction, and it is a chemical reaction in which two or more elements combine to form a compound. An element combines with a compound to form a new compound, or a compound combines with another compound to form a new compound. So it can be any way. It can be in any way. Shape or form. It can be two elements, one element, one compound, or two compounds, or anything of that sort. At the end, you will only get one result, that is, you will get a new element, a new compound, or again a new compound. So it can be of any way, shape, or form. It can be in any way, shape, or form, right? Now, some examples would be here given below, right? Oxidation of non-metals and metals, as you can see, S plus O2 gives you SO2, C plus O2 gives you CO2, 4P plus 5O2 gives you 2P2O5, right? Then 4Na plus O2 would give you 2Na2O, then 2Ca plus O2 would give you 2CaO, then 2Mg plus O2 would give you 2MgO. Similarly, reaction of acidic oxides and basic oxides with water, right? SO2 plus H2O would give you H2SO3. So as you can see over here, you have many examples in which elements are combining, elements with compounds are combining, two compounds are combining. So you have different examples that basically just prove the direct combination reaction or the synthesis reaction. All right. Now, this table basically just talks about metallic elements and non-metallic elements. When they're combined together, they can either form soluble or insoluble salts. It really varies. Then in the next page, these examples are continued, and we see other examples such as burning of hydrogen, then manufacturing of ammonia, etc. So let's go through each of them and let's see how the synthesis or direct combination reaction is taking place. Starting off with the first one, hydrogen burns in air to give water. That's a very easy one, right? Then manufacturing of ammonia would be by the reaction of nitrogen with hydrogen under specific conditions. You get 2NH3. Then preparation of sulfuric acid by the dissolution of sulfur trioxide in water. You get H2SO4. Then moist hydrogen gas combines with chlorine in presence of diffuse sunlight, right? So you get 2HCl, that's a gas. And it basically just says each reaction which is a gas, which is a solid, and which is a precipitate, etc. It has all the details given over here. Now, one homework that I'll give you all from here is that go through each and every reaction that you see in the entire textbook. Write each and every reaction down and write how they are formed. Many questions, especially in chemistry exams, you can get many, and I cannot say how many, just random questions like an active metal reacts with dilute sulfuric acid, or a direct combination reaction between phosphorus and a neutral gas, right? So they can just tell you to balance these equations, or they can just tell you random equations that I don't want you guys to be lost in your exam. So each and every reaction that you see in this textbook, write it down in a paper, and please write in the comment section below if you have any doubts regarding all of this. Alright, and if you can, post the picture in the comment section below. You will get a shout out in the next video as well. I'll be doing a giveaway very soon as well. As soon as I get all the responses and homeworks from you guys, I will do a giveaway that soon. Okay, well, moving on. Now let's move on to our decomposition reactions. Alright. Decomposition reactions, as in decomposition reactions, are chemical reactions in which a compound decomposes to form two or more elements, a compound decomposes to give a new compound and an element, or a compound also decomposes to give two new compounds. All right. Now, some thermal decompositions of oxides, hydroxides, carbonates, and nitrates are given right here. Okay, K to Cu, stable heat. Okay, these are the substances formed. So this is, you can see, 2HgO plus, under the presence of heat you get 2Hg plus O2, that's mercury oxide plus mercury. Fine. Then you have hydro oxides, carbonates, nitrates. So there's nothing really to learn in this. Just read through the whole thing and you'll understand each and every reactions. Again, if you have any doubts, post it in the comment section below. There's nothing really to explain in this because they're just normal reactions in which the decomposition reactions take place. All they're doing is two or more compounds decompose to form, one compound decomposed to form two or more compounds, and they're basically just saying what all happens. All right. Moving on to the next page, over here you can see other examples with heat on ammonium dichromate. Ammonium dichromate, an orange compound, decomposes violently with flashes on light, leaving a green residue of chromic oxide. So as you can see over here, these little explanations that's given, right? All the how the reactions happen, what's the color, how it decomposes violently with flashes of heat. All of these, they can give you a question like, write the chemical equation down. Ammonium dichromate, an orange compound, decomposes violently with flashes of light, leaving a green residue of chromic acid. Balance the equation and write the following equation. So if you have not read these equations, you will be completely lost. So I repeat this again. Take a paper, write all of this down, write each and every detail as you see over here, ammonium dichromate, an orange compound, and all of that down. Make sure that you write each and every chemical equation down because it is extremely important. Take my word on it. All right. So be it thermal deassociation or electrolytic decomposition or photochemical decomposition or just decomposition reactions in metallurgy, anything at all, just write everything down. And once again, if you have any doubts, please post it in the comment section below. I'll be more than happy to solve them. All right. Moving on with the next page where we talk about the displacement reaction. Okay, this displacement reactions are chemical reactions which take place when an element or radical has replaced another element in a compound. It is represented as x plus yz gives y plus xz. Now, in this, as we already know, displacement is a plus, let me write it in a darker form so that you understand better. All right. Yeah. A plus BC gives you AB plus C or AC plus B. So it can displace in any way, shape or form, not only A plus say a CB, depends on the oxidation state of each metal or non-metal, but of course that is how you displace it. So in this case, say your displacement reaction, you'll need to know the oxidation state of each element and how they'll displace with one another. All right. And the ability of an element to displace another is determined its relative position in the electrochemical series, and a more electropositive metal displaces a less electropositive metal from its aqueous solution. Same in the case of electronegative nonmetals. So let's take a few examples in this. Okay. Zn plus Cu SO4. So in this case, Zn and Cu, Zn has a more electropositive state. Why? Because as you can see over here, Zn comes before Cu. So Zn can easily displace Cu with SO4. So it will become ZnSO4 plus Cu. Similarly, Cl2 plus Br. Look at this. Let's go back here. Cl is, where is Cl? Let's find Cl. All right. Okay, well, Cl is not there in this table, but one thing that is there is K. I'm very sorry. Yeah, one thing that is there is K, and as you can see, K is the most strongest of all, right? It has the most power of all, so it is very clear that it can displace this off, right? So a more electronegative non-metal with a less electronegative non-metal. Now in this case, if you want to ignore this K, right? Cl and Br are non-metals. So Cl is a more electronegative, like a more electronegative non-metal. So it displaces Br with it. Then other examples would be metals like magnesium, aluminium, zinc, and iron displace copper. Fine. And then metals above hydrogen in the electrochemical series, that is active metals, are seen to displace hydrogen from dilute acids, and the reaction is used for preparation of soluble salts by the displacement reaction. So the table is given over here. The most strongest is potassium, then you have sodium, calcium, magnesium, aluminium, zinc, iron, lead, hydrogen. Hydrogen is not a metal, but it still comes in the series. Then you have copper, mercury, silver, lead, and also gold. Perfect. Now let's move on to our double decomposition reaction. Alright, double decomposition reaction, precipitation. So double decomposition reactions are chemical reactions in which both reactants, that's compounds, are decomposed to give two new compounds by exchanging their radicals. It is represented as, let's say, XY plus AB gives XB plus AY, or you are exchanging the radicals over here. So in this case, as you can see, A plus B minus plus C plus D minus. So the radicals are being exchanged and A goes to D plus B goes to C. Positive will always come first, so C goes to B. So it will be CB. So AD plus CB. Precipitation reactions, reaction between two compounds in aqueous solution state to give two new compounds, one of which is soluble. Insoluble is called as the precipitate. Examples are given right over here. All of these. And the use of precipitation reactions in analytical chemistry for identifying the positive radical in a salt by analyzing the color of the precipitate. Alright, so with this we come to an end of the first part of this chapter. If you have any doubts, post in the comment section below. I'll be more than happy to solve them, and until next time, bye.